Welcome to the VCO layout demonstration. We start out by matching the differential pair on the left. Upon hitting the equal icon and clicking onto the matched FETs, the differential P-cell form, aka DPC form, appears. The DPCs come in a tremendous number of configurations. The user can select the number of rows and dummies, drains and source metal, strap widths, and other properties. We are proceeding to match the rest of the differential structures, then move them into proper locations at 3x the speed, not to bore you. The A bind key will align the devices within the lasso box that you selected. The alignment form is more powerful than automatic placement. The DPCs provide perfect matching both at the interior and for the routes getting to them. The power supply mesh are synchronized to the DPCs and never cause mismatch to the devices nor the routes that emanate from them. You can see the matching as we click onto the routes. We're going to continue to take our time and place the devices for routability. You can see the alignment form being used. Lots of options in those alignment forms. Very powerful. Setting everything up for automatic routing. You could add pre-routes if you like. You click onto the layer and the net in the schematic. You can see the matching of the nets. Let's automatically route the VCO. The router form provides lots of options. You can see the matched nets. Here's the router form. Okay, we're going to run the C extraction. This form allows the user to pick the CX, RCX, selected R along with C, and we employ major RC reduction to speed up your simulation time. The schematic will show the total C on each net, and the capacitance between a selected net and all other nets appear in the tooltip as you click onto each net in the schematic. Let's simulate with and without the C extracted net list. We have placed analysis and measurement components in the schematic. We are currently running Smash. Our tools also incorporate Zeiss, which is a free simulator. The Results tab will show the measurement values with and without the C extracted net list. The C extracted waveform is shown in blue. The operating points at the clicked waveform time point for each FET is shown in color. Green is saturation, yellow is subthreshold, blue is triode, and red is cutoff. Hover over the devices to see more operating point information. The next thing we will do is run electromigration, aka EM. Click the EM button in the corner that you want to save where your test bench saved your terminal currents. We're then here we go. We're going to be setting up the EM in the test bench, and then after the simulation is run, we're going to push down into the DUT. We need to know what test bench was used to save the terminal currents. After running EM extraction on the layout, we're going to be able to see all the segments and vias that have exceeded the current percentage ratings on the EM percentage pull down on the upper right. Right now we're still running the extraction, and soon we're going to click onto the EM percentage pull down on the upper right. Click the IR icon and then 2 points along the net to see the voltage drop, resistance, and the currents at each point that you click onto.